I'd like to demo simple IoT synchronization, how we're using NAT's Jetstream streams to simplify this. So this is Cliff from Beck Systems. Simple IoT is a project I've been working on for a long time, and recently we switched to using NAT's streams, Jetstream streams, and this is drastically simplified how we synchronize data between systems. So in this setup, I have two simple IoT instances running. There's an upstream and a downstream. And this sync node connects to the upstream. And once I start that sync, you'll see that the downstream node is now present in the upstream. So if I make a change here, notice you'll see it in the downstream. Likewise, if I change it on the downstream, you'll see it in the upstream. And this is just bidirectional synchronization. The idea is we could have a web UI in the cloud and at the edge. And either side, you can make changes either side. So then the other thing we get with streams is history. So let's look at our data for this, and let's say we turn off the synchronization, and notice what happens over here. This data is being generated by the downstream instance, but it's being graphed by the upstream instance. So we have a sine wave generating data here. It's getting sent to the upstream instance via the synchronization, and then it's getting written to this Victoria metrics database, which is then graphed by Grafana. But notice no data is coming in now because we disabled sync. But if we re-enable sync, what happens is there's a stream being written on the downstream instance. So as soon as we re-enable sync, that whole stream gets synchronized, or at least the missing data. So another thing we can do is shut off the upstream node. So I'm going to kill the upstream node, and you'll see it go offline pretty soon. And if we look at our graphs, we'll notice that data quits coming in again because we're saving it to a database in the upstream node. So we see the data has stopped flowing. And I'm going to restart the upstream node again. And there's a back off algorithm on the downstream. So right now it's delaying 16 seconds, but yeah, you can see it already caught back up. So the last thing I want to demonstrate is because we have streams, we can also do things like queue up data if the database is offline. So we could, if we shut down this Victoria metrics database, let's go ahead and do that. Okay, now if we go over to Grafana, we'll see there's no data because it's trying to get data from the database, and there's nothing there. Let's go ahead and start the database back up. Notice we see data. It's still not filled in yet, but the DB client, again, is going to retry in a little bit. Oh, there it goes. So what happened here is the stream on the server, or the upstream, has the data. And if it can't write to the database, it just kind of remembers where it last wrote. And then when the database comes back online, it writes the missing history. So there's several things that are really useful about this property of this offline or catch-up synchronization. And one of them is you can take down an upstream service, the database or the upstream simple IoT node at any time. You can update it, you can fix some problems, move it to a new server, whatever you want to do. And then when you bring it back up, you haven't lost any data because everything downstream is caching the data in a stream, so it's always available and it will always catch up. So this is super nice for operations because I don't have to worry about taking down a service to do some maintenance or whatever. I can take it down at any time, fire it back up, and everything is still there. So this is, I could talk a lot more about the synchronization, but it's very simple because these streams just have a counter that increments with each message that's written. So on both sides, we can just simply look if what the index is, and we'll know immediately if we're caught up. So it's a little tricky when you have downstream and upstream nodes, and where do we write this data? And what I've settled on is basically at each device boundary we create new streams. So like everything in this upstream node is in one stream, and then as soon as we hit this device boundary here, all this stuff here is in another stream. And then it's complicated further by either the upstream or the downstream can write the data, and you can't really write them to one stream. So what we have is two streams for each embedded device. And what that means is there's a stream for data flowing this way, and there's another stream for the data flowing from the downstream to the upstream. And then to determine the present state, we look at both streams and just pick the point at the end of the stream with the newest timestamp. That's how we determine the current state. It works really well. It's like I said, it's very simple, and this is the kind of thing NATS does very well. The other thing Simple IoT gives you is you can just define nodes and points in this tree anywhere you want, and you don't have to worry about streams and synchronization and all that. Simple IoT takes care of creating the streams that you need, making sure they're up to date. Your only job is to create these nodes and the clients that sit behind these nodes, and then just generate points, and Simple IoT does the rest. So that's offline synchronization. Let me know what you think.